All right, today we're going to pull back the curtain on a manufacturing process that is so fundamental, so everywhere. You've probably used a dozen things made with it before you even had your morning coffee.
Just look at these. They might not seem like much, but these little metal components are, and I mean this literally, the backbone of our modern world. They're tucked away inside your phone, inside the car you drive, the appliances in your house, even in the solar panels generating clean energy. They are absolutely everywhere.
And that brings up the big question, right? How in the world do you make millions, sometimes tens of millions, of these complex parts, each one a perfect clone of the last, and do it fast enough and cheap enough to end up in everyday products? Well, the answer is a real marvel of engineering. It's called progressive die stamp.
So let's get into how it actually works. The whole concept boils down to a perfectly choreographed sequence. We're going to follow a single ribbon of metal as it goes on a pretty incredible journey, being transformed station by station.
Okay, so picture this. A huge coil of metal, like a giant ribbon, is fed into a massive press. Now, with every single powerful thump of that press, the ribbon scoots forward to a new station. At the first station, maybe a hole gets punched. Thump. At the next, an edge gets bent. Thump. At the third, a logo gets stamped in. This goes on and on, step by step down the line, until at the very last station, a perfectly finished part just pops right off the end. It's like a symphony of different operations all happening in one continuous fluid motion.
And that, right there, is progressive die stamping. The key thing to remember is the automation of it all. It's a single tool, what's called a die, that does this entire complex sequence. And believe me, that die isn't just some chunk of metal. It is the highly engineered, genius-level brain behind the whole operation.
So if the giant press is the muscle, the die is definitely the brain. The real magic of this whole thing isn't just the raw speed. It's the absolutely incredible, mind-bendingly complex engineering that goes into designing the die in the first place.
You know, as the folks at JV Manufacturing say, the secret to all this efficiency, it's all in the design. Building one of these dies is this amazing mix of physics, material science, and pure craftsmanship. And it's all focused on one single goal, making a perfect part millions and millions of times without fail. And the number of things a designer has to get right is just staggering. You have the strip layout. That's the master plan for how to cut everything to waste as little metal as possible. Then you've got carriers, which are these tiny little metal bridges that hold the part and carry it from one station to the next. And pilots! These are critically important pins that line up the metal strip with microscopic precision right before each stamp. It's wild. Every single element has to work in absolute perfect harmony.
And make no mistake, this is not your grandpa's old-school metal shop. Engineers today are using this powerful digital toolkit. They use 3D software to simulate exactly how a piece of metal is going to bend and flex. They can even predict issues like springback before they even cut the first piece of steel. They run what's called a failure mode and effects analysis, or FMEA, to basically predict problems before they happen. And yeah, AI is even getting in on the action, helping to optimize the designs and even predict when a tool is going to wear out. It's this incredible fusion of digital smarts and physical precision.
But even a perfectly designed die is only one part of the equation. To get a perfect part out the other end, you need two more critical things. You have to start with the absolute right material, and you need a super strict quality control system checking the work every single step of the way.
Choosing the material is a huge decision. You might go with steel for something like a car's frame because it's strong and pretty cheap, or you might pick aluminum because it's super lightweight and easy to shape, which is perfect for things like EV parts or heat sinks. And for electronics, you gotta have copper alloys for their amazing electrical conductivity. The material you choose changes everything about how you design the die and how that final part is going to perform.
And quality control isn't just a quick check at the end. Oh no, it is a constant journey. It starts before anything is even made by testing all the raw materials. It continues during the process with real-time monitoring and statistical process control, that's SPC, to catch tiny errors as they happen. And then finally, after the part is made, it's measured with these unbelievably precise machines, like coordinate measuring machines, or CMMs, to make sure every single dimension is perfect.
So we've seen the process. We've seen the incredible precision that goes into it. Now let's kind of zoom back out and talk about the sheer scale and impact this all has on, Well, on everything.
Get a load of this number. Some of these high-speed presses can crank out up to 50,000 parts per hour. Let that sink in. That is more than 13 parts every single second. That mind-blowing volume is what makes all of this so cost-effective. It's how these complex, essential metal parts become affordable enough to put in everything we use.
And that speed, that scale, it literally powers our most critical industries. We're talking about everything from the brackets holding up solar farms to the tiny, precise connectors inside our phones and laptops. The boom in electric vehicles has created this massive new demand for stamped parts like heat shields and battery components. So yeah, the next time you pick up pretty much any piece of modern tech, there's a very, very good chance you're holding a product of this amazing process.
And that brings us to a final thought here. We've seen how this tech has already evolved with digital tools and AI. But as our gadgets get smaller and more complicated, and as we demand even tighter precision and new kinds of materials, how is this powerful 100-year-old process of stamping metal going to keep reinventing itself to build the world of tomorrow? It's a fascinating thing to think about for the future of how we make, well, everything.